Good afternoon, everybody. This is Ms. Varna. I'll be the host for today's program. On behalf of the Math Club and the Staff Development Committee of the Department of Information Technology, University of Technology and Applied Sciences, Muscat, I'm honored to host the virtual talk titled Configurational Analysis in Management Research using fuzzy set, qualitative, and comparative analysis, to be presented by Dr. Sanjay Kumar Tyagi, Assistant Professor of Mathematics, Department of General Studies, Higher College of Technology, Fujairah, United Arab Emirates. At the outset, it's a great pleasure for me to welcome Dr. Sanjay Kumar Tyagi, our resource speaker, Dr. Bushra Al-Sulaimi, our head of the math section, and all faculty members. It's my honor to invite Dr. Ibrahim on behalf of HOS to present the welcome address.
Good afternoon, dear participants. I am Dr. Ibrahim, a faculty of Math section in the IT department of University of Technology and Applied Sciences. It is indeed a great pleasure to welcome you all to this special event today. On behalf of the head of the section, I invite you all for this today's special program, a talk by my friend Dr. Sanjay Tyagi. Today's talk is one of the series of events organized by the Math Club of Utah every semester. The speaker today is Dr. Sanjay Tyagi, who was formerly a faculty in HCT Muscat, known for his academic excellence, both in teaching and research. And above all, he is a wonderful human being with admirable qualities. It is indeed a great pleasure to invite him and all participants today for this talk. Thank you. I request Ms. Anna to take over from me.
My dear participants, we have two announcements. Firstly, your mic will be kept muted during the presentation. However, you can post your questions, if any, in the chat box. After the completion of the virtual talk, you can unmute your mic and ask your questions directly to the speaker. Secondly, the feedback link will be sent to your mail ID within 2 days. Once you submit the filled in feedback form, your certificate of participation will be automatically generated. So first, let me give a brief introduction of Dr. Sanjay Kumar Tyagi. Dr. Tyagi received his PhD degree in mathematics from CCS University, Meerut, in India in 2006. He was formerly a faculty in HCT Muscat here, known for his academic excellence, both in teaching and research. He is currently working as an assistant professor of mathematics in the Department of General Studies, Higher College of Technology, Fujairah, UAE. He is the author of more than 30 research papers in various international and national journals of repute such as IEEE Transactions on Fuzzy Sets and Systems, the Electronic Library, Neural Computing and Applications, Applied Mathematical Modeling, etc. He has authored or co-authored 5 books in the area of mathematics. He has been a reviewer of research articles in IEEE Transactions on Fuzzy Sets and Systems, Optimization, Taylor and Francis, Journal of Manufacturing Processes, LCVR, International Journal of System Sciences, Process Safety and Environmental Protection, LCVR, etc. His research interests include fuzzy and intuitionistic fuzzy logic, information systems, theory of decision-making, and reliability analysis. Dr. Tyagi has been awarded the designation of the Certified Expert for Digital Teaching and Learning by Blackboard Academy, USA. He is a life member of the Indian Mathematical Society, India, and is a member of IEEE. I hope you all will enjoy and benefit from his insight and perspectives. Thank you for joining us today. Dear Professor, now it's your time to share your knowledge with us about the topic, configurational analysis in management research using fuzzy set qualitative and comparative analysis. Dr. Sanjay Kumar Tyagi, please continue, sir.
Hi, everyone. Once again, a very good afternoon. And first of all, let me thank Ms. Varna for such a nice introduction and using these encouraging words. I'm sure I will try my level best to keep your words high. And I would like to extend my gratitude to the organizers of this event for giving me the opportunity to be part of this virtual talk. And a special thank to Dr. Ibrahim Sejat, who has been, I have been, I mean, maybe for more than 1.5 years, I have been in Muscat, and he was for me, was one of the guiding force and a colleague, and more than that, my elder brother. And I appreciate all his efforts to approach me and to introduce me to such a learned audience. So thanks once again to all for joining this event. And as I mentioned, and you can see here, this is a virtual talk. So I would like to make it more like dialogue, not a monologue. I feel particularly in an online session, that the audience might get bored if if the speaker is only means there is a one side. You can say if someone is only speaking, the audience may get bored in listening the same person for a longer time. So what I decided actually to make it something like a dialogue, and I will be using one interactive tool to make it, just a two-way conversation. So I would like to share the link for a Nearpod. You just need to click on that link, enter your name or your, ID, whatever, just a nickname, and join that session. So here is the link in this chat box. You can just click on that link and share that Nearpod session. So I will be using Nearpod throughout this talk. So my humble submission request to all of you to join this Nearpod session by clicking on that link. I hope you all can see the link in the chat box. You can join it either on your device by clicking on that link, or if you want, you can type join dot, let me write another way also, join.nearpod.com. You can type this on your mobile and use the code. Here is the code, okay? If Ms. Swarna permit, let me share my screen. Can I share my screen, Ms. Swarna? Yes, I think here I can.
Yes, doctor.
Okay. So you can see it on my screen as well. You can type join.nearpod.com on any device, maybe mobile, maybe your tab, and then use this code to join the session. It will help me actually, and all of us will be, we can share our opinion on the talk, the topic which we will be talking about. If you are there, we can start. Let me check here. 8 people are there. So I will request once again you all to please. I will share the link once again. Not, sorry, link. I will share the link once again. Can we start now if you all are in? You can join using that link. Okay, let's start here now. So here we will be talking about configurational analysis in management research using fsQCA. I tried to shorten the title actually on request of Dr. Ibrahim. So here are the key highlights of this talk. So firstly, we will be discussing about classical set versus fuzzy set. Of course, we all might have gone through the classical set theory since we all belong to the math fraternity. Then we will go to fuzzy set operations. Some set theoretic operations we will talk about only. And then finally, we will discuss fsQCA, which is an application of fuzzy set for some, you can say, information systems research. And I will try to demonstrate this fsQCA using one illustrative example. Okay, so let's begin with classical set versus fuzzy sets. As I mentioned, since we all are from, math background. So first, let me know how you define set actually. It will be easy for you to, just connect the concept of fuzzy set, connect with the concept of fuzzy set. Let me know if you can, sorry. You can share your opinion on this collaborate board. How do you define set? Your opinion only. You can, you can define, you can narrate in your own words. It will be easy for me even to illustrate fuzzy set or how you can connect set, the classical set to fuzzy set in your own words or in your own way. So I'm waiting for your opinion on this collaborate board. You can just type here. So I see here one from Ms. Nisha, collection of objects with some common characteristics. Okay, good. A set is well-defined collection of objects. Of course, this is what we have been taught and we have learned again and again and again. Set is well-defined collection of object. Okay, good. I see here collection of well-defined, same from Saji, from Dr. Kolapan also, set of well-defined object from Dr. Avinash, well-defined collection of object. Yes, of course. So I believe this is well perceived definition of this classical sets. Okay. If you have something new, please share your opinion with us. Otherwise, we will go to the definition of classical set. Yes, of course. A set is a well-defined collection of objects. And if I say well-defined collection of objects, Dr. Manisha, may I request you to join the nearport session and please use that collaborate board because we have few more activities. So I will request you to please join that nearport. Okay. So as I mentioned, it is a well-defined collection of objects. So what do you mean by well-defined? So here well-defined means we need to define the criteria which can decide who are within the set, who are outside, means which are member, which are not the member of a set. Okay. So if I say not the member means usually this something universal set is hidden, but it is well known that a set is defined on a universal set. So the members of universal set may present in a set A or not. So those which are present in the set A, we can define here now. You see here another definition here now, or the characteristic function. What this function is doing? This function is mapping all elements of a universal set. A membership degree 1 or 0 means 1 for those who are within the set and 0 for those who are outside the set. So this is how we define a crisp set for classical set. Okay. Now the question here is how can we transform it into fuzzy set? So fuzzy set is not something like something alien. Of course, the mathematicians only derived that concept. They only coined the concept of fuzzy set. And how they I mean invented this? They use the same definition of fuzzy set, sorry, crisp set. So what they did, they replaced here, you see here, this function here, characteristic function is mapping the universal set elements onto a set 0, 1, having only two elements 0, 1. This is a set 0, 1. But if you go to the characteristic function of fuzzy set, it is mapping the elements of universal set to an interval 0 to 1. So now the membership degree may be 0, 1, or any number in between, right? That was not the case in case of classical theory, classical set. We had two choices, yes or no. Here, no. We have yes, no, and in between, many more. So fuzzy set can be considered as an extension or generalization, or you can say an oversimplification of classical set, right? So this is how we will move. Let me demonstrate here now with the help of one example, because you see here, now I take here now a finite set A, and the term here is the set is high temperature. So if we talk about the classical set, we need to define the term. Okay, if you remember, I was emphasizing on the term well defined, well defined. So if we here use the same thing, well defined, so we have to define what is high temperature. So we can say high temperature is something 40 or above. So you can see here in the universal set, I try to demonstrate with the help of this Venn diagram. So in the universal set, you can see here, there are many values of temperature starting from 18, 15, 18, 22, 25, 38, and many more, right? And you can see here, the temperatures which are more than 40 are within the set, within the circle, and which are less than 40 are outside. So there is a clear-cut boundary. But did you observe one thing? Just merely with the difference of one unit means, or even less. So say, for example, if the temperature is 39.5 or 39.2 or even 39, that temperature will not be the member of this set high temperatures. On the other hand, so just merely a difference of one unit made this element, kept this element outside, this temperature outside. But on the other hand, a gap, a difference of, you can say even 15 units, keep them all in the same family. You can see here, 51 is or 55 is treated high temperature. On the other hand, 41 also treated high temperature. So they all belong to a same family. They all have same capacity, same capabilities. Okay, same regard. But is it the case in our real life situation? No. So what we have to do here is, now I try to generalize the concept of high temperature in terms of fuzzy set. So in fuzzy set, all elements of universal set are the member. Okay, so we will not disappoint any element. We will not say, hello, you are not in, you are out, get out and sit outside. Okay, you are not in our class, you are not here. I mean, there is no racial treatment with any element of this set, universal set at all. So what we are doing, but now your question may be, if we are keeping all inside, how it is possible? So we can do that. And here what we are doing, we are assigning a membership degree, a varying membership degree. So the temperature which is highest, that may have higher degree of membership, something very close to 1, because 1 is the highest membership value. Okay, so for example, you can see here in the 55 temperature 55, membership degree is 0.96. 51, it's something 0.85, again, not very far from 1. But the temperature which is going very far from 55 means which like 15, 18, they have their membership grade near to 0. Okay, very close to 0. Like in case of 15, the membership degree is 0.01. And in case of 18, it is 0.08. I hope it helped you to get an idea about the difference between classical set and fuzzy set, right? Okay, we will take the questions later, but I will give you opportunity to interact using that collaborate board again. Okay, another something like you can say contentious thing, and I will not say contentious, but I will say confusing, is fuzzy logic versus probability. The membership grades for a fuzzy set are, of course, between 0 and 1 inclusive, and same are the values of probability. So many scholars are confused with if there is any similarity between fuzzy logic and probability, or are they same? No, they are not. As we all know, probability is what is probability? It is something like we can say quantitative measurement of a likelihood of an event or quantitative measurement of uncertainty. Please underline the word uncertainty because I will be using the same for fuzzy set also. So we have something uncertainty in fuzzy also. We will be using the same term uncertainty in probability. So what is happening here now? In probability, of course, there are two outcomes only, yes or no. Probability of yes or probability of no. Okay. So what is fuzzy then? Fuzzy theory or fuzzy logic? It is based on linguistic information. If I use the same temperature, high temperature is something, high is a linguistic term. So for you, high temperature may be, say for example, us living in the Gulf, high temperature is something 50. But think about someone who is living in Europe, in some parts of Europe, or in some, you can say, I mean, parts of Himalaya, where the temperature, high temperature, something like 15 or 16 is also considered to be high. Okay, so this is something varying, or you can say subjective concept, right? And where the things are defined on the basis of partial truth. Okay, because we assume we can assign some varying degree to any amount of truth there. Suppose I say like we assigned high temperature 50, we had the membership degree something near to 1. Okay, temperature reduces, we can assign a varying degree, but we cannot do the same thing for probability. Let me do one thing. I will try to illustrate with the help of one example the difference. Okay, go ahead. See here now. Suppose we say there is a 59% chance that there will be a storm today. So based on some data, some atmospheric pressure or some other parameters, right? The meteorology department may say there are 59% chance that there will be storm today, right? This is probability. This 59% is probability, okay? But on the other hand, we say the weather will be stormy, right? So weather will be stormy. That is only this. So stormy weather is a fuzzy set. Now, how you define, say for example, the wind speed or the atmospheric pressure, whatever parameter you use. Suppose you say wind speed. The wind speed, different speeds will be assigned different membership grades. So up to different, you can say extent, the speed, if the wind speed is this much high, then the chances, or not chances, sorry, then the weather is stormy. The membership grade for the weather to be stormy is this one, so and so forth. I hope it helped you. Or let me take one more example. Suppose you are thirsty and you are, just you can say on a desert drive and you need water. There are 10 bottles of water, okay, lying on, kept on a table. You know only one bottle has drinking water. Others are having some poisonous, some contaminated, water actually. One bottle has pure water, drinking water. Others are poisonous. We can assume like that. What will be the probability of the bottle? You select one bottle. What is the probability that water is drinking water? The water bottle you pick is drinking water. So one bottle has drinking water, other 9 are having poisonous content. So total are 10. So the probability will be 1/10, or you can say 0.1. But that is not the case with fuzzy logic. If I again use the term drinking water, and I assign now, there are 10 elements. X1 means suppose first bottle, X2 means second bottle, so and so forth, up to 10. Only one bottle will have membership degree 1. Others will have membership degree 0, because only one bottle has this drinking water. So this is how you can differentiate between probability and fuzzy set or fuzzy logic, because it is something, a very contentious issue actually. Okay, I hope you got some idea about fuzzy set, how we transform from classical to fuzzy set theory, and then what is the difference between probability and fuzzy logic. Okay, move on. Now, again, here is a collaborate to, have a conversation about fuzzy sets. I don't know why it's taking too much time. Usually it does not. Okay, here is. Can you see the whiteboard? Can you see the whiteboard? The collaborate board. Can you see the collaborate board on Nearport? Is it visible? If yes, okay.
Just local.
Okay.
Yeah.
Okay, yes. So now, what difference now you observe between classical and fuzzy sets? I need your opinion, your thoughts. So since we have discussed classical set, how we transform to fuzzy set, may I request you to share your opinion, your thoughts on the difference between classical and fuzzy sets. Feel free, okay? This is not something like a classroom. Of course, this is a conversation. You are, we all are, you can say, on the same page. And I don't feel that I am something delivering a lecture at all. I see here many senior colleagues of mine, and I'm fortunate enough to work under their leadership. And many names are still known to me actually. I could not meet in person, but I know. So I'm waiting for your opinion. What difference you observe between classical and fuzzy sets? Okay, let me throw one. Okay, okay, I see from Dr. Kalappan here. Fuzzy set is more complete than classical set with better coverage. Yes, agree. 100% agree, Dr. Kalappan. Yes, of course. Because it is a generalization, okay? There we had only 2 choices, yes or no. Here we have many more. Even infinite number of choices we have. Yes, I expect my respected audience to share their opinion. Okay, more opinion need to come. Yes, please. So fuzzy set, you can say the difference between fuzzy, okay, difference between their membership grades. it has more coverage, like Dr. Kalappan is saying, it has more coverage than classical. No? Shall we move then? Okay, I don't know if some internet issue is there or what. Anyway, let's move. Okay, we have from Ibrahim sir. In classical set, on element is either out or in. Yes, sir, of course. And in fuzzy set theory, element will be a member of a set with degree of membership. Yes, with varying degree of membership. Yes, of course, sir. Very well said. Very well said. Yes. Anything more? So what Ibrahim sir is saying, there is a difference between classical and fuzzy set theory. And that difference comes from the membership grade, membership degree. Okay. Membership degree for classical set theory is only two choice, yes or no. But here we have more. Okay. Thanks for your opinion. Let's move on. Okay. Now we come to the operations on fuzzy sets. Here we will be more or less, we will be focusing only on set theoretic operations, but there are few more, but I will leave for you to, I will refer you some literature, you can investigate further. Operations on fuzzy sets, and we will be, as I mentioned, we will be emphasizing only on fuzzy set theoretic operations. See here, if you remember, in classical set theory, if we have set A, and I ask you the complement of set A. So if there are, suppose, 5 members in set, suppose, I say in general, 1, 2, 3, 4, 5, suppose. We have the universal set having 10 numbers, 10 numerals, 1 to 10. And if I need here the complement of set A, which was having 5 elements, so the complement, of course, we all are aware of it, will be the elements which are not in set A. This is how we define complement in case of classical set theory. It's almost similar thing we are doing here. So if we have a fuzzy set A and mu A is representing the membership grade of any element X in fuzzy set A. What is the membership grade of its complement? Suppose the membership grade mu of X in A, fuzzy set A, is 0.4. Then the membership grade of its complement will be 1 minus 0.4, means 0.6 only. Okay, and this here, why I call standard fuzzy complement. In case of set theory, classical set theory, only unique operations we have, means the complement of set A will be unique. But that is not the case in fuzzy set theory. No, please remember. In case of fuzzy set theory, there may be more than one complement of any fuzzy set. But in case of classical set theory, no. A is set, A complement will be unique. That's it. But here, there might be different complements of fuzzy set A based on different, as per the literature, there are several actually. I'm not going in detail. You can study it further. Similarly, we have standard fuzzy intersection. Of course, standard fuzzy intersection and union are defined in a similar manner. But why I am using the standard here in all these 3 operations? Because there may be more than one fuzzy intersection for 2 fuzzy sets A and B, like I said for complement. So this is the difference. But why I am using standard here? These standard fuzzy complement, standard fuzzy intersection, and standard fuzzy union are analogous to the complement, intersection, and union in classical set theory. But as I mentioned, in fuzzy set theory, we can have more. So please remember, in fuzzy set theory, these set theoretic operations are not unique. No. Okay. unlike classical set theory. So this is also, I mean, we have to take care of. So these are few aggregation operations, but all aggregation operations are not covered by these three operations. No, there are few more. Like if we need to aggregate, and of course, in fuzzy set qualitative and comparative analysis, when we will be discussing about fsQCA, there we need to aggregate, okay, fuzzy sets. And what operations we can use to aggregate? We can use, of course, fuzzy union, fuzzy intersection, and there are few more aggregation operations like mean, median, ordered weighted average functions. There are many ordered weighted average functions which are invented, I mean, by different authors. And T norms and T conorms are intersection and union. So T norms, in case of fuzzy, T norms is intersection, fuzzy intersection. If I say norms, means there are more. And conorms are known to be unions, fuzzy unions, right? So other than these T norms and conorms, there are few more like mean, median, ordered weighted average functions, as I mentioned earlier. So these are aggregation of fuzzy sets. So I hope now you have some better idea about fuzzy set theory, the difference between fuzzy and classical, and the aggregation operations on fuzzy set, means set theoretic operations on fuzzy set. Now we have one activity here. I'm not here to test the knowledge of any of my audience here. I know we have a learned audience, but just to, I mean, just to play with this, I mean, it's just an activity here, just to play with what we are learning here, to make it more interactive, to make it more two-way, so that I can know, okay, my audience is, I mean, just, okay, they are picking it well, and they are enjoying with it, okay? So I will be using this activity here. It will be having 6 questions. You can answer 6 questions. Each question is time bound. So please answer correctly and within the prescribed time. As soon as you answer, you will get better grade. Suppose we 2 players are participating in the same. I answer correctly. Suppose someone else answered correctly. Suppose Ibrahim sir is answering the question. Swarna ma'am also answering the question. Suppose Swarna ma'am answered before Ibrahim sir. So Swarna ma'ams will have better score, okay? So here time and correctness of the answer matter. So let's go to Himalaya, okay? And here this activity begins. So you can join by using any of the avatars on your device. Okay, I see here Dr. Danasekar is there. Okay, yes. So ready to go Himalaya. Though it's a winter time, you will enjoy your hiking on Himalaya. Nisha ma'am is there. Okay, so please, I see here. Sayed sir is there. Okay. Please. We are waiting for more to come in. I hope you will enjoy this trekking on Himalaya. Yes, please be quick, because other will be feeling cold otherwise. So we have one more. Swarna ma'am is there. Syed Mustafa sir is there. Okay. Sajid Mohan is there. Yes, guys. Okay, Farhan sir is there from IT, I think, if I'm not wrong. Farhan Kapoor sir. Okay, good. Okay. Yes, guys, please. Okay. Don't have much time. We can't wait for more because others are feeling cold. So let's start our journey. Okay, here we go with the game. Yes. Answer as quickly as possible. Okay, time is almost up. Okay, your answer is on the top. Okay, the possible membership values for a crisp set. Crisp set means classical set. Crisp means classical set. What are the possible membership values for a classical set? Okay. 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 Good contest going on. Wow. Good. Appreciate, sir, everyone. Okay. Third, possible membership values for fuzzy set. Be careful. Now the question is for fuzzy set. Okay. 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 Good. Good. Okay. Nice contest. Appreciate. Okay. This is little bit time taking. So you have enough time. 90 seconds I gave here. So now we need intersection. So if you remember, intersection was minimum of the membership grades. I'm giving some hint, and I hope now you can pick. So there are 5 members in both sets A, B, A and B, having varying degree of membership, and we need their intersection. Yes, please. 38 seconds are remaining. If you know the answer, be quick to respond, please. It needs concentration, attention. That's it only. Of course, all are knowledgeable. The only attention is important, actually. And time up here. So Swarna ma'am is on top now. Okay, great. So be careful. Okay, now same sets and the union only now. Union. Same set A and B, but now we need union. Standard fuzzy union, I'm asking here only. Standard fuzzy union. Okay, 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 okay. Time is there, but if you know the answer, please attempt it as soon as possible. Okay. Around 40 seconds are remaining. So please be quick. Good, good. I think the top 3 contenders are not, leaving any stone unturned. They are holding their post. Okay, 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 okay. Oh, what happened? And the last question here is, like classical set theory, the fuzzy set theoretic operations are unique. Oh, I think I gave more than enough time here. So operations are unique or not? In classical set theory, we have unique operations, but here in fuzzy set theory, are these operations unique or not? By mistake, I gave more than enough time. My apology. I think it will be running out now. Okay. Yes. So let's see here. Ibrahim sir is on the top, then Sajid mom, Dr. Kamal. Wow, good. Appreciate all for your participation, active participation, in fact. And let's move on. Okay. So now we come to here the application of fuzzy set theory. Of course, we all know fuzzy set, fuzzy logic can be applied in different parts of our life. Okay, starting from economics, medical science, information systems, and different social or managerial researches. But here we will be discussing about fuzzy set qualitative, comparative, fuzzy set qualitative and comparative analysis, fsQCA. So the question might be arising in your mind, what is fsQCA? I don't know if you have heard about fsQCA earlier or QCN. Okay, so tell me one thing here. Okay, one thing you might have heard. Suppose we have two variables, one is independent, one is dependent. Or let me make it a little bit complex. We have one independent variable and one dependent variable. My apology. One dependent variable, suppose y, and two independent variables, x1 and x2. We collect data for them. To establish the relationship between them, what techniques we use? We may use regression analysis. Since we have two independent, so we can use multiple regression analysis. In some cases, we can use, even if we have more independent variables, we can use structural equation modeling. So those who have a statistics background, they might know it better. But of course, regression analysis is known to all of us since we are from mathematics background. This fsQCA, I'm not saying is a substitute or any generalization. No, this is a different approach which can be used in place of statistical methods, whether it is multiple regression analysis or you can say structural equation modeling. So let's go through it, what it is. So of course, now I hope you will have the answers to all your queries coming to your mind. What is fsQCA? This is a combinatorial method to investigate the determinants of any phenom. Okay, so determinants means the variables, independent variables I will be using here now. So you can call them independent variables or factors, suppose. Say, for example, I take one live example. Suppose our outcome here, our dependent variable here is spread of COVID-19. So there may be several factors behind the spread. Okay, because it is a contagious variable, so it can spread from person to person contact, or maybe because of low immunity, maybe because of comorbidities, or maybe some other factors behind it. So using statistical methods, we can find the factors, the impact of these factors on this outcome, the dependent variable, I mean, COVID-19 spread. Here in fsQC also, we are doing something similar, but here we can do a combinatorial analysis actually. In statistical methods, no. That is linear additive analysis or linear additive relationship of independent variables. Right? So this is the major difference between fsQCA and statistical methods. All, whether it is SEM, structural equation modeling, I mean, or multiple regression, the genesis, I mean, you can say the both methods are based on correlation. These all statistical methods are correlation based method. Here it is not. This is a case-oriented comparative approach. So if I say case-oriented, here case means respondent. Suppose I prepared a questionnaire and I shared the questionnaire to all my learned audience. Suppose I see here 50 people here. So I share my this questionnaire to all of you and I collect the data. I do statistical analysis. In statistical analysis, I may know the individual effect of factors but I cannot investigate which respondent responded in favor or against. Here in fsQCA, since it is a case-oriented comparative approach, here we can identify which respondent. If I use the word case, it means respondent. Which respondent responded in favor of solution or against the solution, right? So there are two benefits here now. One is we can find the configurational analysis, combined effect. There we cannot. The second important here, the importance here is, means how it is different from them, is it is doing a case-based study actually. So it is something like where we can investigate further. Suppose 10 people are supporting, 5 are not supporting, then we can approach to them. What are the reasons behind your support or your, or your negation? Means if you are going against. In fsQCA, this is another important aspect here. The empirical argument must be subordinated. Say, for example, here we collect the data and then we establish the relationship in case of statistical methods. And we say, hello, this is the relationship. There in case of fsQCA, no. Your data may show some relationship, but there must be a theory supporting that relationship. If there is no theoretical perspective in support of your empirical argument, then it has no, you can say, use. It is waste actually. But there we cannot. Many times you see many things happen. We say, hello, I have data in support of me. But here you can't say only data will work. No, there should be something, some theoretical argument, or you can say some theoretical expectations here now, right? Next, and the last here, it is a set theoretic approach, of course, which we have discussed, and which operates on membership score. So here we will be using membership degree, and I will show you how we can use that for this causal relationship between the outcomes, means the dependent variable, and the factors, the conditions, we call them independent variables also. Okay. Why fsQCA? Many arguments I have given even earlier, and there may be even more. With my limited knowledge of this fsQCA, there are 3 major reasons for using this fsQCA, and I have thrown some light even in the previous during our discussion of the previous slide. And what they are equifinality, causal asymmetry, and conjunctural causation. Conjunctural causation means configurational analysis. So third we have discussed, but I will show you, I will demonstrate it further with the help of an example. And I will, before that, even I will demonstrate with the help of some pictures what is conjunctural causation or what is configurational causation. I don't know if you have heard the word equifinality or causal asymmetry. Causal asymmetry might be used because you know why I'm asking? Because this equifinality, I heard first time when I was studying this fsQCA. So my apology. I'm not, just you can say gazing anyone's knowledge. But since you heard it first time while studying fsQCA, that's why I'm asking. If you have heard about equifinality, may I know? You can share on the chat box if I don't know if you can share. Anyone heard about equifinality earlier? The first term, equifinality. Yes, anyone? No? I hope I'm audible. Am I audible to all?
Yes, sir.
Okay. So equifinality means See here, it is something concept of multiple paths to a common outcome. This is called equifinality. I don't know, I see many of my learned audience are from India. So of course we are, and of course in Oman also, in UAE also, we are a multicultural society. And here, I don't know if you have ever heard about, there is one verses in I think in Rig Veda, Ekam Satya Vipra Bahuda Vadanti, means the truth is one, but scholars interpret in different way. So this is the literal meaning of equifinality, means you can reach to one God in different paths through different faiths. Same is here. So the outcome, the desired outcome can be reached by different paths. In case of statistical analysis, no, there was only one optimal solution. We call that optimal solution, and that was linear additive relationship. Okay, it was linear combination of independent variables, which was resulting in the dependent variable, or I say outcome. Here, no. We can have a solution which may be a combination of 2, 3, 4, or more number of independent variables or factors. If I use the word factor, condition, or independent variable, they are same. And then one more thing we have to take care here, these paths may be different, means mutually exclusive, or may not be mutually exclusive, means they may be overlapping as well. That is also allowed. Means some traits are common in two different paths. Two paths are different, but there are some traits common in them. Okay, that also allowed. So this is called equivalent. Causal symmetry means what? See, if you remember, if I want to investigate the effect of X, means the independent variable on Y. So what we do, we use regression analysis and we get one equation here, there. And the same equation can be used for negation. We do not generate another equation for the negation, means for not of X, Y. So the same relationship, suppose I get one equation y equal a plus bx. The same equation will work for not of y. But in our real life situation, that is not the case. There are many different things in between. I mean, y means yes and no. Means any outcome y, if it is defined, if we have a different path with or set of solutions for y, that solution, negation of that solution is not necessarily be working for negation of y. This is called causal asymmetry, right? Let me move further because I think we might be running out of time otherwise. If anything you want to ask, you can keep your question. We can discuss at the end, as Swarna ma'am discussed in the beginning. Or you can, leave your question in the chat box also. I'm regularly checking chat box as well. Conjectural causation, as I mentioned earlier, that linear, correlation-based methods are not, you can say, giving us combined effect. Say, for example, if you might have observed, let me go back to the same example of COVID-19 spread. You might have observed one thing here. The casualties, the mortalities were more for old or some people which were having some ailment, maybe some diabetes or sugar, or maybe some other comorbidities. So what was happening? This virus, it was combining it with, co-joining with these, comorbidities, and it was leaving a severe effect. on our body. Okay, so that severe effect means that combined effect cannot be measured using statistical methods. For that purpose, we need fsQCA or any conjectural causation method. We can, of course, go to the complexity theory also, but here we will focus only on fsQCA. Okay, so these are the basic, which we will be, these are the basic things, which makes this fsQCA different from any statistical methods. Okay, now the next step is, okay, doctor, you are talking more about fsQCA, and of course you are advocating and championing for fsQCA. How we perform it? There are different softwares in the available, and many of them are, you can say, free softwares or open source softwares. And most important, I think the most commonly used software is fsQCA software. So you can download that software and you can do some practice if you have some data, raw data with you. But what are the steps? And any fsQCA methodology or fsQCA analysis can be performed in the following steps. Here they are. We start with calibration or aggregation of data. Then we construct truth table. Thereafter, we minimize truth table. Using truth table, we just, gather some configurations, some combinations of factors, and then we interpret those configurations. Are they useful or they are not? Okay, so what I did, I will try to demonstrate this fsQCA methodology with the help of one example. Let me take one sip of water. Yes, please come back. Okay, what is calibration here now? If, as I mentioned here, when we collect the data using any questionnaire, we usually use Likert scales, maybe 5-point scale or maybe 7-point Likert scale, whatever, right? So when we use the Likert scale, we collect the raw data on this Likert scale for independent variables and the dependent variable also. So here, this independent variable is perceived usefulness, but perceived usefulness of any system or any device cannot be measured using one, single question. As per the literature, there are different set of questions. We call them indicators or survey items. So there are different survey items. Here I use survey items, 3 survey items in our research. We use 3 survey items to collect the data for perceived usefulness. And there are many more variables. Say, for example, I will show you here and then come back again. Perceived usefulness, perceived ease of use, PEOU means perceived ease of use. SQ stands for system quality. IQ stands for information quality. And SEQ stands for service quality. And then the CIU is the dependent variable, which is continuous intention to use a system or a device. So here, all these variables are measured using different survey items. So I'm taking example of one only because due to the scarcity of time or limited space, I could not put all of them on the slide. But I'm just trying to demonstrate with the help of one independent variable how the data can be collected. So when we collected the data for perceived usefulness of one system, these are the respondent. Maybe suppose 3 respondent I collected here, just again due to the limited space available on the slide. Because in our data, we have 209 responses, but I took here only 3 to demonstrate. This respondent, suppose for any research, this is me, who responded 1, 1, 1 for all these 3 survey items. second responded 3 for first question, 2 for second, 4 for third question, so on and so forth. And same is something by the third. So how we calibrate this data then? As I mentioned, calibration is something transforming our raw data, this Likert scale data, into membership grades. So we can use different membership grades, different, you can say, methods. We can assign a triangular membership function or a trapezoidal membership function. And as per that function, we can convert these values into membership grade. But here in this fsQCA software, there are some inbuilt operations, calibration methods, which you can employ, and they will automatically convert all these Likert scale values into membership grades for all independent variables and the dependent variables, right? So after calibration, now what is the next step here? So calibration was the first step, simply transforming Likert scale data to membership grade. Okay, done. Let's go to the next here now. Here is how the data after calibration and aggregation, I aggregated also. If you see here, perceived usefulness had 3 variables. And if you remember, in the beginning, I defined some aggregation operations that could be union, intersection, or maybe few more. So using those operations, those operations, I aggregated now. So we have only one value for PU, using all PU1, PU2, PU3, so on and so forth. And this is how the data looks like. Okay, aggregated data and calibrated data it is for all independent and dependent variables. Okay. After the calibration, what is the next step? It is truth table. Okay, of course, those who might have studied Boolean algebra, and particularly people from IT department, of course, they know it better than anyone else. Truth table, okay? We use the concept of truth table. Say, for example, here, in my case, how many independent variables we have? 1, 2, 3, 4, 5. 5 independent variables and 1 dependent. So we have 5 independent variables. So if we construct a truth table, there should be how many rows? We know it, 2 to the raised to the power k. Okay, so 2 raised to the power 5 means 32 rows must be there, having different combinations of 1 and 0. So we construct a truth table having 32 rows for my data. Suppose you have only 3 independent variables. So the truth table for you will have only 8 variables. 8 rows. 8 rows, not variable, rows, please. Okay, now you construct a truth table. What is this meaning of truth table here? Truth table means, hello, I am writing all possible combinations of all these 5 variables. So we have 5 variables, PU, PEOU, blah, blah, whatever they were. So I wrote all possible combinations of these 5 variables. So now the question here is, can we consider all these combinations? We have 32 combinations. We cannot be that much liberal, not at all. Okay. So if we are so liberal, then there is no use of this analysis. You accept all combinations then, but we cannot. We need to select only those combinations which are empirically supported, which are supported by the data. And how we will find, how we will underline, how we will shortlist those configurations. Those configurations, the shortlisting of those configurations is called minimization of truth table. So this is the step here now. As you can see, again, I could not list all those 32 rows, but I tried to list a few here. And you can see only 3 configurations are supported by the data. 145 people, 145 responded supported this configuration, first one, 3 supported second configuration, and 2 supported only the third configuration. And none of the remaining configurations are reported by, are supported by our empirical data, means by any respondent. So these all are residues, and we omit them, we truncate them. And that process was something called minimization. So we truncated all those rows, and we get only these configurations. So these configurations are useful for us, and they have, I mean, different support. And one more thing you can observe here. You can ask me, while you are truncating, while you are deleting the residues, how you define residue? It is again a subjective case. It depends on you. You means how many respondents are supporting. So the first configuration is supported by 145, second by 3, third by 2. You can say, hello, I need the configuration which need to be supported by at least 3 cases, means 3 respondents. Then the third configuration will also be a residue for you. But someone says, hello, I want to consider 2 also. If 2 respondents are supporting any configuration, I need to include it in my analysis. So therefore, any configuration which is supported by less than 2 respondents will not be included. Here, by the way, there is not a single supported by 1 respondent. So here, this frequency of cases supporting these responses again depends on the researcher, means on you, whether you decide to the frequency to be 2, 3, 4, 10, whatever. But in general, we consider 2 actually. The most accepted value of frequency is 2. Okay, let's move on. So this was the process of minimization. So you finally found 3 solutions here now, 3 configurations. They are, you can say, causing your outcome continuous intention to use a system. Now comes the interpretation, means how you will say this configuration I mean, it is useful or not useful. Means like you remember in statistical methods, we propose an hypothesis, then we do the analysis, and we say this hypothesis is accepted, this is not accepted, blah, blah, whatever. Means null hypothesis is rejected or not rejected. Depends on the p values or the z values or t values, whatever, whichever, I mean, method, tool you are using there. Something similar is here. So we define here now the coverage. So based on the coverage, so in other words, first let me say one thing here. We have 3 solutions here now for the outcome, 3 causal configurations for outcome CIE, which is sufficient and how much sufficient it is. So we will be talking about sufficient, but there are 2 actually different things we use in fsQCA: necessity and and sufficiency. Sufficiency is more acceptable way of interpreting the data. So I will also be emphasizing on sufficiency here. So which configuration is sufficient and how much sufficient it is? Is it, I mean, adequately satisfying or sufficient enough for this outcome or not? So we set again a yardstick, a bar. If this is the sufficiency, then we will say yes. If this condition for the sufficiency is not satisfied, we will say, hello, this configuration is not satisfying the outcome. It is not leading to the outcome as per my satisfaction level. So that satisfaction level will be determined with the help of 2 parameters, coverage and consistency. So first, let me show you what is coverage here. So coverage, as you see the name here now. If I say we have two paths, path 1 and path 2, means two configurations. How I will determine if one of them only is sufficient, both are sufficient, or if I combine both of them, are they sufficient or not? So sufficiency, again, as I mentioned, is depending on coverage. If I say coverage, means how much Y is covered by in this configuration. I say suppose path 1. That will decide if this configuration is covering enough amount of outcome or not. So if I say outcome, as you know, in fsQCA, all these variables, dependent, independent, whatever, they are considered to be set. And if you see in Venn diagram, we can depict a set as a circle in Venn diagram. So outcome circle you see here, it is covered by path 1 and path 2. And I observe the coverage of path 2 is slightly more as compared to the coverage by path 1. So path 2 is the sufficiency level of path 2, the coverage of path 2 is more as compared to path 1. Now, if I'm talking about coverage, this coverage is categorized as row coverage or unique. Row coverage means overall coverage by the path, whether it is lying, it is overlapped by another path or not, we don't bother. So we just simply say, hello, how much coverage is there? How much area of the outcome is covered by that path? Even if it is overlapping with another configuration or path, we don't bother. That is called row coverage. But if I want to check the individual coverage by that path, means not overlapping with other paths, that is called unique coverage. So based on some criteria, some you can say acceptable percentage of coverage, row coverage and unique coverage, we will say this path is sufficiently covering the outcome or not. So this is how we interpret our analysis. Then comes consistency. The another tool, another parameter used to interpret the analysis is consistency. Now, consistency also you see something similar here. In both cases, we are using almost similar thing. But can you observe the difference? In coverage, we check how much Y, means the outcome is covered by the configuration. That was coverage. In consistency, we determine how much this configuration is within the outcome. Means how much it is included within the outcome Y. So if we see here now, the first case A, I mean the first scenario, X1 is not fully covering Y, no. So we cannot say it is 100% covering. The coverage percentage of Y by this combination X1 is 100%. No, this is not. But consistency is 100%. Means this X1 is 100% included within the outcome Y. This is called consistency of sufficient condition. Let me check one message is there. Okay, that's it. Okay. Let me come back here now. And if you see here, in scenario B, in case B, that this consistency is not 100%. Means this solution, this configuration is not 100% involved within Y. It is not included completely. So here, the consistency level is less. As compared to B, the consistency level in case C, means scenario C, is even lesser. So this is how we differentiate between coverage and consistency. Many times I have seen some scholars are confused between consistency and coverage. So coverage is with respect to outcome, Y, and consistency is with respect to independent variable or configuration X. This is the difference between them. So based on this, what we did, we conducted the analysis, using our 5 independent variables and the dependent variable. And this is how we put the data in our table here. And if you remember, when I was defining the coverage there, the row coverage and unique coverage of configuration, the first configuration are 0.8528 and 0.03, right? I will try to depict it, illustrate with the help of Venn diagram again, which is specifically for this problem only. And you can see the configuration, consistency, and row coverage, unique coverage is here. When we decide which configuration is sufficient or not, we don't look at unique coverage. Unique coverage is just to get an idea, okay, is there something which is uncommon in any configuration? That only. But we don't bother about unique coverage. The acceptable limits are set only for consistency and row coverage, okay, not for unique coverage. So how much overall any configuration is covering the outcome, the desired outcome, means dependent. And this is the pattern, this is the way how we prepare this table. In this table, you see the dots, black, these dots they mean that in this configuration C1, the first configuration, this variable PEOU, perceived ease of use, is present, PU is present, but SQ may be present or may be absent. It hardly makes any difference. Okay, means the presence or absence of SQ is not affecting the outcome, the desired outcome. Okay, in second configuration, this perceived usefulness, second variable, is not affecting, means the presence or absence is immaterial for second configuration. But the question here is are these two configurations satisfied enough? Means, they are sufficient enough to, you can say, to cover or to, define, or you can say to be the appropriate solution for this? Yes, they are. Because the consistency for both are more than 0.9 and row coverage also more than 0.8. The minimum yardstick, again, it depends on the scholar, okay? But usually the most acceptable limit for consistency and row coverage is 0.8. If the row coverage and consistency are more than 0.8 or equal, then we say this configuration is sufficient enough, okay? And here you see the interpretation of configuration. Again, the same thing I'm listing here, and overall coverage and consistency of the overall means if I combine both of them, this configuration 1, configuration 2, if I combine using or configuration 1 or configuration 2, if I combine them, the coverage will be slightly more, okay? Right? Consistency may not be more, but coverage will be, of course, slightly more as compared to their individual coverage. And this is here all about this interpretation of the analysis, fsQCA analysis. And you can see here, this outcome is something like this yellow color circle. And here you have this first configuration, which is having PU, PEOU, IQ, and SEQ. PU is lying outside the second configuration and SQ is lying outside the first configuration, right? But they are covering a sufficient amount of both of the desired outcome, means output or desired outcome, which is CIU, right? So this is all about fuzzy sets, fuzzy logic, the difference between classical set theory and fuzzy set, and then how we can use them for fsQCA. Here you're welcome. Your suggestions, your questions are most welcome. And this is all from my side. Thank you so much for being such a nice, patient audience. Now it's up to you. If you have any suggestion, any question, please, most welcome. Thank you.
So first, we will see the questions from the chat box.
Okay.
There are no questions in the chat box.
No question. Okay. If you can, you can ask now using the same slide on near port. If you
Yeah.
have any question, please, most welcome.
You can please unmute your mic and you can ask your questions, please.
Yes, please.
Oh. So I hope there are no questions, sir. I hope everything is clear for all the participants.
Okay. Thank you.
So Dr. Ibrahim will express his gratitude. Dr. Ibrahim, please.
Thank you, Dr. Smith.
Thank you, Dr. Sanjay. It was indeed a very, very interactive and very informative speech and quite interesting. And you have inspired us with some new terminology. This first time I'm hearing this fsQCA that I think further we can collaborate on it, maybe if God willing. Okay, thank you very much. As a token of gratitude, we would like to present the certificate of appreciation to our respected speaker, Dr. Sanjay Kumar Tyagi. Thank you once again, Doctor. We will send the soft copy of the certificate through your email ID, and also we will send the hard copy to you through post.
Thank you so much indeed, sir. It was pleasure being with you.
Thank you
all.
very much, Doctor. It was
Okay.
an excellent presentation and it was very interactive and very enlightening session. I hope all
Thank
the
you so
audience have enjoyed this virtual talk. Dear participants,
Thank you.
I would also like to extend our sincere thanks to each one of you for your participation and making our event a grand success. And I would like to express my gratitude to all the esteemed delegates of the webinar for their presence and contribution to make this
Thank you,
webinar a
Doctor.
great success. I take the opportunity to thank Dr. Sanjay Kumar Tyagi for his wonderful presentation, our head of section, Dr. Bushra,
Thank you,
our
Doctor.
head of the department, Professor Tali, and the Dean of the College of Computing and Information Sciences, Utas Muscat, for their constant guidance and encouragement in all our academic and co-curricular activities
Wonderful.
throughout the year. I would also like to thank Mr. Shajid Man and all the Math Club members for their support
Thank you,
and
Dr. Sanjay.
participation in all our activities. So that's the end of the meeting. Now, all the participants can leave the meeting as we are going to end the meeting. Thank you once again, everyone. Thank you, Dr. Sanjay
Thank you
Kumar
so much.
Tyagi, sir.
Thank you so much. Thank you so much, Dr. Swarna, and a special thank to Ibrahim sir and all the audience who were, very patient, and because it was something a new experience for me to interact with my, you can say, with the colleagues in my institution, old institution where I have worked probably for 1 year. Thank you so much and have a good day. Nice weekend to all of you.
Thank you.